A warm welcome to everyone. In this part of video lecture series, I am here to present on the topic climate, temperature, chemical and corrosion effects on concrete. So let us first deal with temperature effects of concrete. Due to rapid changes in temperature, such as repetitive cooling and heating of the concrete structure, due to variations in temperature, there may be freezing and thawing effect on concrete. We already know freezing is the process in which the water molecules present inside the concrete expands due to lowering of temperature below 0 degrees centigrades. So this most severe climatic changes on concrete leads to various cycles of freezing and thawing in concrete. Thawing refers to the changes in temperature which causes contraction in concrete. So what happens during freezing and thawing is the gel pores which contains water freezes at a particular temperature during winter season. Due to this process, the water present inside the concrete expands by 9% by volume, so that the excess of capillary water has to move away outside from the concrete medium. So in this case, it is very difficult for the cement paste to remove the excessive water present inside the concrete. So this results in the formation of crack in concrete, which is due to freezing effect. So it is found that for normal strength concrete, the movement of zero point 0.2 mm of water requires high amount of pressure, which is equal to the tensile strength of the paste. So if the high amount of pressure generated inside the concrete, if it exceeds the tensile strength of the CSH gel, it leads to cracking of concrete. So this can be prevented by protecting the concrete from freezing and thawing effect. In this process, we have to entrain approximate quantity of air so that there will be provision for expansion of the concrete, and also the water molecules present inside can be moved freely inside the concrete medium. So we have to provide a spacing of air bubbles about 0.4 millimeters. The air bubbles remain partially empty in the concrete so that they can accommodate excessive amount of water which is moved as a result of freezing effect. So this constitutes the coarser system of the concrete, and therefore the loss of moisture in the concrete happens and the concrete finally dries. In case of completely saturated concrete, there is no need of protection against freezing and thawing of concrete, but it should be prevented from various other factors such as tidal range, and also should be protected by air entrainment. And next is effect of temperature in concrete. Due to variations in or fluctuations in temperature, it results in differential volume change of concrete. That is continuous contraction and expansion of concrete due to varied climate and temperature. So in this case, the tensile strain experienced by the concrete due to differential volume change exceeds the tensile capacity of the binding media of the concrete, that is the cement paste of the concrete. So if the tensile strain developed due to this differential volume change, if if it exceeds the actual tensile strain capacity, it will be leading to crack in concrete. These temperature differentiations are associated with large heat of hydration of cement, that is the endothermic reaction, and also it affects the mass concrete in structures such as columns, piers, footings, dams, etc. Due to heat of hydration process in the early stage of concreting, that is the reaction between water and cement, leads to increase in internal temperature of the concrete during the initial curing period, which is usually warmer than the room temperature or normal temperature. This may also lead to formation of cracks in concrete. And then finally, in thick sections and rich mixes, the differential temperature may be present in a considerable amount. So these are all the effects of temperature in concrete. We shall see about the effects of corrosion and other factors in forthcoming video. Thanks for listening to this video. Have a good day.